Okay, so in our warm-up today, we're provided with a model. It's an exponential model that represents the amount of online advertising spending between the years 2011 and 2015. The first question that they ask you is, how much did the U.S. spend during the year 2013? Okay. So what you need to do is figure out what is time for 2013. If you're talking about 2011, then t equals 11. So if it's 2013, t equals 13. And this is pretty quick and easy. All you've got to do is plug this into your calculator, substituting 13 in for time. I get something like $40.4 billion. Make sure that you label that appropriately. Today you'll be working with models. You'll be answering questions about people or things or money, and so you want to label it appropriately. For part B, the question changes. In what year will the U.S. spend $80 billion on advertising? So now $80 billion is going to go in for S. So we would plug in 80 billion for S, that's equal to 9.3 e to the 0.1129 t. And then what would you do to solve for t? Divide 80 by 9.3, so I'm just going to write this side as 80 divided by 9.3 equals e to the 0.1129 t. And I know you could put that into your calculator and get a decimal. I'm just going to leave mine as 80 divided by 9.3. I don't really need to know what the decimal is at this moment. And what would we do next? We now have isolated the base e and its exponent, 0.1129t. So we can rewrite it in logarithmic form. You might say using your circle method. That'd be log base e, which is natural log, of 80 divided by 9.3 equals the exponent, 0.1129t. And then at the very end to solve, you've just got to divide by 0.1129. So even though I don't have my calculator up and running right now, I kind of know the steps to solving. And so you can plug this into your calculator. I get something like 19.1 for t, which represents how many years later. But the question is, in what year will I spend $80 billion? So that would be what year? 2019. Is everybody okay with the solving? Do we need to talk about that? Make sure today that as we work through the problems, you are also typing into your calculator. I consider that like a form of muscle memory, so that you know you have once typed in before and you get kind of familiar with that, where you need parentheses, where you don't need parentheses, and it makes a big difference. Okay, we're going to move right along and talk about the last section of Chapter 3. So after today, you have everything you need for your test on Thursday. Really important to do your homework tonight so that tomorrow when we go over the answers to the homework, you know if you're doing things correctly, if you have any kind of questions that you need to ask. And we're talking about exponential and logarithmic models today. So these are going to be applied to like a real world scenario. Some of you might call them word problems. But here we're applying the model to represent something. So we're going to start with just like our compound interest formulas, how we can work with them. And the first example says, how long will it take an investment of $1,000 to double if your interest rate is 8% and your interest is compounded quarterly versus monthly? Or sorry, quarterly versus continuous. Okay, well, that's calling calling on my knowledge of my compound interest formulas, which you should know for Thursday, so make sure that you're studying those. If I read that problem, how long will it take an investment of 1,000, that's my P, to double? So 1,000 doubled would be 2,000, that's my value for A. If the interest rate is 8%, so R is 0.08, and let's all take a moment to say that's way too good to be true. You wouldn't get an interest rate of 8% in the real world. If the interest is compounded quarterly, so quarterly implies n equals 4. So what I would do first is just plug all of this information into my compound interest formula. The one thing that should be left unknown to me is, Nathan says, time, T. Okay, that's the question that we're asking. So $2,000 equals 1,000 times 1 plus 0.08 divided by 4 raised to the 4t. Your job is to solve for t so that you can answer the question of how long it will take, how many years it will be. So what will you do to solve that equation? Work that out. Why don't you work that out with your small groups for me? See if you can solve that equation with your small group. Talk about what steps you would take, how you would type that into your calculator.
So, that's dividing by 1,000.
So then you got 2 equals 1.
And then that 0.08 divided by 4 was a terminating decimal. So 0.02, so I knew that it would have not affected my answer around I did that now. So then I got 2 equals 1.02 for the 4t power.
Okay, we'll come together and see what we've got so far. First step, you want to try to, in this example, it's exponential equation. 4t is in the exponent. You want to isolate the base in the exponent. So the exponent is 4t. Its base is 1 plus 0.08 divided by 4. You got to get rid of 1,000. How will you do it? Divide. Divide by 1,000. 2,000 divided by 1,000 is 2. Now I have a base raised to an exponent all by itself, so I can use my circle method and rewrite it as a log. Remember that when you rewrite it as a log, you have to start at the base of the exponent. So it will be log base 1 plus 0.08 divided by 4 of 2 equals 4t. So I could write that out. Now, you could simplify 1 plus 0.08 divided by 4. That divides evenly to just be 1.02. So you can make your life a little bit easier there. I would encourage you, like, if it doesn't come out nicely, like 0.02 and be a terminating decimal, leave it in the form that we have it right here. That way you'll get a more exact answer so that you're not rounding it. In order to do that in my calculator, I would use my change of base formula. Okay, so I would do the log of 2 divided by the log of all that stuff that is my base. And since my parentheses is open, I can just type in 1 plus 0.08 divided by 4. Apologize, I have to type slowly today because my calculator isn't working. And I get this number. I'm not even really going to jot that number down, although you could if you wanted to in your work. What's the next step to solve? Divide by 4. So whatever I get in my calculator, I'm just going to go ahead and divide by 4. So T equals, and then I'm going to do divide by 4, and I get something like 8.75 years later. Okay. Questions about what we did, how we solved? What would change for part B? Use the continuous compound equation, which is PERT. Okay. It'll be a little bit nicer. 2,000 equals 1,000 times e to the 0.08t. But you're basically going to follow through with the same steps, right? You need to isolate the base and the exponent. That's e to the 0.08t. So divide by 1,000. 2 equals e to the 0.08t. And now you can rewrite in log form. So log base e of 2 equals 0.08t. What's a log base e? A natural log. So a natural log of 2 equals 0.08t. And then I just have to divide by 0.08. Again, practice putting this into your calculator so that you have experience. We don't want Thursday to be the first time you do any solving with your calculator. So I do something like natural log of 2. I've got to close parentheses if I'm going to do it all at once, divided by 0.08. Should be kind of close to my previous answer, 8.66 it is. I would be alarmed if one was like really off of the other. Because you can make money faster by compounding continuously, but it wouldn't be that much faster, like years faster. Does anybody have any questions about either of those? Okay, then let's look at the models. Now, there are really like 2 or 3 models that you're going to be working with in your homework today. The first 2 are exponential growth and exponential decay. Now, what I want to say about the exponential growth and exponential decay, if you look at both of them, they are base E. So essentially, these formulas are the same as PERT. Okay, if you look at that, they're written almost exactly like PERT, but they have different letters. So in this equation for exponential growth model, y is like the A in PERT, that is the amount in your account. So I'm just going to say y is like your total amount or your final amount. Okay? It's your output. A is like the P in PERT, which is your principal, and that's your starting amount. So A represents initial amount. E is the base, your exponent, so it's not something we plug in for, it's the number E. And then we're raising it to the bx instead of the RT. So B is like your rate, and X is your time. Remember that your rate should be entered as decimal, not percent. Okay, so change percent to decimal. Must be true. Or if you're pulling rate out of a formula, you put it back into percent. Okay, so multiply by 100. And then one thing that's interesting about these models is time is more flexible in these models as opposed to like the financial model it was always in years. Depending on what we're working with, we might be talking about years, we might be talking about days, but you can be talking about hours. And these exponential growth and decay models, they could represent population, they could represent the spread of a disease or an illness. So we can use them like carbon decay, half-life, that kind of stuff. So we can use them in a lot of different ways. Okay? And you'll see that in your homework today. Now, notice that it says this is exponential growth when b is greater than 0. Okay? That's because your base is already greater than 1. It's e, 2.718. If you have a positive exponent, then it continues to be growth. On the other one that is exponential decay, I have this written incorrectly where it says, b is greater than 0. That is correct. Notice that this time b is a negative number. So your base is still e, 2.718. If it's raised to a negative, then it's going to flip the base and make it 1 over 2.718, which is actually decay. Okay, so anytime you're working with a model and it has a negative exponent, that's going to be exponential decay. Okay. The other model that you see at the bottom of your notes is what we call the logistic growth model. And I kind of referenced the logistic growth model at the very beginning of the chapter. Remember how we did that kind of like zombie story? And we said at some point, if we quarantine the school, everybody's going to be sick, so there's not that many people to infect. So that happens for a lot of things like population and illness and things. It's going to increase really fast at some point, and then that rate of increase is going to kind of level off because there aren't as many people available, or things available to be, I want to say, infected. So that would be only for disease. So that's your logistic growth model, levels off in the end. The only thing you're going to have to do with the logistic growth model is work with an equation that's given to you. So you're not going to have to write logistic growth models, you just have to be able to work with them. Okay, let's look at our first example. Here we're going to write an exponential growth or decay. In a research experiment, a population of fruit flies is increasing according to the law of exponential growth. So immediately when you read that, you know which equation to pick. Exponential growth is y equals a times e to the bx. I should have a positive exponent if it's going to be growth. After 2 days, there are 100 flies, and after 4 days, there are 300 flies. How many flies will there be after 5 days? I want you to take a quick moment with your group, reread through that problem, and just identify the things that you know from the information they provide you and what that would apply to in this exponential growth model, y equals a times e to the bx. So what do they tell you? And what does that represent in the model? Okay, go ahead and have a quick conversation. See what you can come up with. Okay, let's see what we came up with. They give you some information, right? Do they give you any of the information you really want? No.
Well, oh, so you're saying that could be the initial amount? There has to be at least 2, but I could have started with more than that slice, couldn't I?
I don't know.
So I did hear in the groups as I was walking around some discussion about, is 100 the initial amount? And we would all say no, because it's 2 days after the beginning, right? So t equals 0 is going to be your initial amount, and we don't know what the initial amount is. So what are these things that they're getting me? 2 days, 100 flies, 4 days, 300 flies. If it's not initial amount, what are they providing me with in my equation? Pairs, ordered pairs, which represent x and y, time and the amount of flies, right? So after 2 days there are 100 flies. Elise could write that as 2 100. After 4 days there are 300 flies. We could write that as 4 300. And knowing that those represent my x, y ordered pairs, I could plug those things in for x and y respectively. So if I'm looking at that first ordered pair, I could say 100 equals a times e to the, and I would do b times 2. I'm going to go ahead and write that as 2b, because multiplication can be written either way. Now that's kind of trouble for us, right? I mean, we still have 2 unknowns, and they're really the things we really like to know, the initial amount and the rate. Using my second point, I could write an equation that says 300 equals a times e to the 4b. But I have the same problem. I still don't know my initial amount, and I still don't know my rate. This is like a system of equations. You have 2 equations in 2 variables, so you can use some method to solve for both variables. I'm going to use substitution. So what I would do first, I'd write out my 2 equations, and then I'm going to solve for a. It doesn't matter which equation you start with. I'm going to go ahead and start with my first one. 100 equals a times e to the 2b. How would I solve for my initial amount if it's being multiplied by e to the 2b? Divide by e to the 2b. So I'm going to divide both sides by e to the 2b. A is equal to 100 divided by e to the 2b. So now I have a in terms of b. If you can write one variable in terms of the other, then you can do substitution. So I'm going to sub. A equals 100 divided by e to the 2b in for a in the other equation. So I could say 300 equals 100 divided by e to the 2b times e to the 4b. So solve for one variable. A is going to be the easiest one. Just divide. Okay. Plug that into the other equation, and now you'll have an equation with only b's in it. So you should now be able in some way to solve for b. On the right side, I've got a lot going on. I have essentially 100 e to the 4b over e to the 2b. How can I simplify that? E to the 4b over e to the 2b. Q. What happened to your 2b? E to the 2b if you just made it over 1. Oh, or you are making this side over 1. Yeah, okay, so you could rewrite this. These things get multiplied. If the parentheses bother you, this is what it is. Yeah, you could make it e to the 4b over 1 and then multiply them. How can you simplify e to the 4b over e to the 2b? Subtract your exponents. You have the same base. You're dividing powers. You may subtract your exponents. Okay, so maybe make a note in your notes here, subtract exponents. So I get 300 equals 100 times e to the 2b. That looks a lot better. I don't have so much stuff going on. And now I can solve for my exponent. This would be more like the problems you did on your homework last night, in the warm-up today. First thing you got to do is divide by 100. So that's 3 equals e to the 2b. You have the base and the exponent all by itself, so you can turn it into a log, and it's log base e, so it's going to be natural log 3 equals 2b, and then just divide by 2. I'm okay at this point in this problem if you go ahead and get the value of b as a decimal. I would just say don't round to the tenth. You're going to see me here when I do natural log of 3 divided by 2. I'm going to say maybe go 4 numbers after. It just gets me a better answer in the end. So 0.5493 is my b value. 0.5493. Yes, thank you. No, this is the rate. Remember, b is the rate. So we still have to find the initial amount. Okay. So look back at your work. Remember, originally we had this a equals 100 times, or 100 divided by e to the 2b. Step 3. Sub b equals 0.5493 into find a. So to me, the easiest way to do it is to go back to my step 1. A equals 100 divided by e to the 2 times 0.5493. And I'll pull up my calculator. And I just have to type that in. 100 divided by, and then I'm going to pull up my e. Some of you might have e with a parentheses. Just make sure that you do 2 times 0.5493 behind the parentheses. And that's equal to 33.33. So that's my initial amount of flies. And then, of course, there's that question. Do you mean you started with 33.3 flies? No. But mathematicians are less bothered, like as you go higher up, than for putting like a decimal there. Have you ever heard the statistic, the average family has 1.2 children? Okay, obviously, there's not 0.2 children out there, but we're okay with that, so that doesn't really bother us. Okay, so what did that stuff all do for me? Why is that helpful? What can I now do? Okay, so we have A, the initial amount, we have B, the rate, and now we can plug those into our model, and like Abby says, plug that in with time 5, and we'll have the number of fruit flies, or number of flies after 5 days. Okay, so I'm going to write my model real quick. That would be y equals 33.33 e to the 0.5493x. That's just the model. If you're ever asked about writing a model, it should be in terms of x and y. And then you can use the model to answer the question about later dates. Okay, y equals 33.33 e to the 0.5493 times 5. And I think I get something like 519.5 flies. if that bothers you, you could round to 519 slides. You don't have a whole slide. I'm okay with that, but it doesn't bother me to stay decimals. Other questions about that process? That's probably the most involved work that you'd have to do. Okay, then we're going to look at the last one. The last one is one that is an example of the logistic growth model. And remember, you don't actually have to write the logistic growth model. I'm just going to be basically asking you some questions given a logistic growth model. So, on a college campus of 5,000 students, one student returns with a contagious disease or virus. The spread of the virus is modeled by this formula, so this is being provided for you. Y is the total number of students affected. The college will cancel classes when 40% more students are affected. So I asked the question, how many students are infected after 5 days? What do? Plug 5 in. Yeah, that's going to be easy. Y equals 5,000 divided by 1 plus 4,999 e to the negative 0.8 times 5. Now, the one thing you'd have to be careful with in the logistic growth model, if your calculator doesn't separate out your fraction into like actual numerator and denominator, because you have this addition in your denominator, 1 plus something, you'd have to put a big parentheses around your denominator. So you would do like 5,000 divided by, and then open up parentheses for everything that's in your denominator. I come up with 54 students, I think. Anyone confirm? Did you type that in? Maddie says I'm good. So you can attempt to type that in and see if you can get the correct answer there. We do want to take a look really quickly at after how many days the college will cancel class. So what do you know about when the college cancels the class? What's that? When 40% of the student population is infected, right? So we need to know what is 40% of the students. How would you calculate that? 5,000, the total student population, times 0.4, which is 2,000. So we know we will cancel classes when 2,000 people have been affected, so we can sub 2,000 in for Y. So 2,000 equals 5,000 divided by 1 plus 4,999 e to the negative 0.8. So that's similar to like that second question that was in our warm-up. When will we spend $80 billion? Now we got to solve backwards. Just a couple of quick things before the bell rings. If I were solving a logistic growth model, what I would do first is multiply both sides by the denominator. So cancel out the denominator on the right, and then on the left I'll have 2,000 times 1 plus all that stuff. But now I don't have a fraction. And I want to solve for t. I don't want t to be in the denominator of a fraction. Then I can divide by 2,000. So I have 1 plus 4,999. 5,000 divided by 2,000 simplifies nicely, so I don't mind if you write it as 2.5. Otherwise, leave it as a fraction or write more numbers after the decimal. And at this point, it should be pretty easy, like in terms of reverse PEMDAS. Subtract 1, divide by 4,999, and then rewrite as a natural log. So now you kind of got rid of that whole fraction issue. I I think this one will come out to be 10 days. So if you want to jot that down, you can double check that you can get it to 10 days. Please take some time. The homework is not a lot of problems, but they will take a little bit of time. But do some problems so that you know what kinds of questions you have tomorrow.